All right, there were some questions. Question number 8, don't worry about. Okay, these are 3 that somebody wanted me to go over because I went over them quickly at the end, and I'll go over the other ones that we were starting. At the start of the next class, it says hydrogen gas reacts with iodine gas at constant temperature in a sealed rigid container. The gases are allowed to reach equilibrium. According to the equation above, which of the following best describes what will happen to the reaction immediately after iodine gas is added? So seeing here, it's talking about changes in rate. All right, if you add I2, you get more collisions between H2 and I2, so that'll speed up the rate of the forward. The reverse stays the same, so now the rate of the forward reaction becomes greater than the rate of the reverse. The value of the equilibrium constant for the reaction above is 1 times 10 to the 10th. What is the value of the equilibrium constant for the following reaction? So they flipped this and doubled it. So that means to the k, okay, the k, we will now take the reciprocal of it and square it. Okay, so 1 times 10 to the 10th becomes 1 over, all right, and we're doing 1 times 10 to the 10th times 1 times 10 to the 10th. Add the exponent, you get 1 over 1 times 10 to the 20th, which is the same as, 1 times 10 to the negative 20th. This is the last one. Okay, this relates to, again, solution chemistry. All right, so you have a saturated solution. This one I started with. Okay, so saturated means it's at equilibrium, meaning the concentrations are constant for the solution. It says 1 milliliter of the sample is removed every 3 days through evaporation. So just the H2O will leave, but since it's saturated, right, the maximum amount of CuSO4 is dissolved. Okay, it's at the solubilities of the ion, or the concentration of the ions are at the point where you multiply them together, you get the KSP. So they're going to stay that way. So the only way they stay that way is if some of the ions dissolve, precipitate back out, okay, making that the SO4 minus 2 concentration is the same, because since that's moles per liters, the liters are evaporating out, and the moles will precipitate out. All right, so that's why this answer is as more water evaporates out, more CuSO4 precipitates.